Yulia Sion. I'm a researcher and industry expert in haptics and wearable technology. Today we are diving into the world of fluid reality, the future of haptic technology, and what lies ahead in this exciting field. I'm joined by two fantastic guests, Craig Shultz and Joe Mullenbach. Craig is an assistant professor of electrical and computer engineering at the University of Illinois College of Engineering and co-founder of Fluid Reality. He specializes in interactive embedded systems and haptic actuation. His work has won 6 Best Paper Awards and nominations at premier ACM and IEEE venues, and has been featured in venues such as NBC Nightly News with Lester Holt, TechCrunch, and more. Joe Mullenbach has spent his career focused on the physical interface between human and machine. He's a researcher and technologist in the field of haptics. Joe is a co-founder and CEO of Fluid Reality, a technology startup producing the first practical high-resolution tactile displays to let humans feel what robots feel in teleoperation. This work has been honored with numerous awards, including as a Fast Company Innovation by Design Honoree 2024. Joe was an early employee at haptic touchscreen startup Tanvas and holds a PhD in mechanical engineering from Northwestern University. Hi guys, hi Craig, hi Joe. Thanks for your time to be here. It would be very interesting to have you here and talk about haptics. How are you?
Very good.
Very good. Very good. How are you?
Happy to be here.
Great. It's the first time actually I'm interviewing a duo, let's put it that way. And I think you're very nicely having both same interests, and also you've been working before together, right? As I understand, like for more than 10 years.
That's correct.
So usually, like traditionally, what I ask my guests is to talk about their journey into haptics, right? Because I mean, haptics community is very small, generally speaking, right? And it's always very interesting to know, how did you get into this direction of haptics precisely? Could you please share briefly your career path?
Yeah. So for me, I was visiting different research labs, thinking about going to graduate school, and I went to Ed Colgate's lab at Northwestern, and he had a demo there that he showed to me, and it was this little box, little screen, and you could slide your finger around the screen and bounce a little ball against your fingertip. And it felt like when I came into contact with the ball that I was hitting something real. Right? It was bouncing off my finger. And then I could roll a little pencil, imagine a 6-sided pencil and what it feels like rolling underneath your fingertip. So I felt that, there are a bunch of other little demos like that, little switches and stuff, all on this little perfectly flat glass screen. And I felt that, and I thought immediately, like, this is the future. I wanted to be a part of it. I've always been interested in the application of technology. So not just, understanding, how the world works with science, but building things that, make people's lives better, that really impact the world. So when I felt that, I was hooked. Obviously, Ed is amazing, and Northwestern is great. So everything was awesome there. But that was the moment that I really got hooked on haptics.
So that was in your grad school, right?
Yeah, that was just before grad school. That was when I was deciding. Yep.
So you joined what department did you join? How did you start getting involved in haptics in your graduate then school, right?
So I became a PhD student advised by Ed and Michael Peshkin, and then began studying that technology, began studying surface haptics. That's how I first met Craig. I was building an open hardware project called the TPad tablet. And the idea was to take this surface haptics technology that had been developed in the lab by a bunch of mechanical engineers at Northwestern and get it out in the world so that people who are doing interaction design, computer science, people who are building products can start to experiment with it and figure out how to really put it to use. So Craig was a new, super bright electrical engineer. I was a mechanical engineer, and I was super excited when he agreed to start working with me.
Okay. So that's when the collaboration started, right? much
Yeah.
we didn't have on. All right. What about you, Craig?
Yeah, so I've always been like fascinated by computers. I built my own computers and stuff growing up. And then my father is a surgeon, and he used the intuitive surgical robot in his kind of day-to-day surgery. And I got an internship at Intuitive right after undergrad, their electrical design group, and was just surrounded by all these people doing, teleoperation and robotics and all this kind of crazy stuff. And I was like, I've never seen this before. Like, how did you guys learn how to do this? And a bunch of the graduates from Ed Colgate's lab at Northwestern were working there. And they kind of introduced me to Ed's lab. And then one thing led to another. And I applied to Northwestern after discussing things with Ed a little bit and really wanting to dive into this really interesting emerging area of, humans interacting with computers with their hands in this really complex kind of nuanced way. So I joined Ed's lab, I moved to Chicago, and then just dove into kind of whatever projects were on the table. And Joe handed me a project to look at. And as we discussed, it was the Surface Haptic tablet. And yeah, we were kind of off to the races at that point. We both have a background kind of in human-centered design and a kind of a passion for that as well. So it just made sense to kind of take that technology and move it forward. And then that led to my further work in my PhD working on surface haptics as well.
Mhm. I see. Well, I noticed that both of you mentioned like the first encounter with haptics and being fascinated with applications, right? Like this future applications, like you, Joe, mentioned the future of interactions, right? In a sense, future of interacting with machines in a way. So we'll talk about compelling use cases a bit later in our conversation. But I'd like to continue and talk a bit more about the state of haptic technology nowadays. And I would like to maybe cite you, Craig. On your website, you mentioned the following thing, and let me just read it. You mentioned that the sense of touch remains underutilized when it comes to how we interact with the computers. And then you say, I believe the primary reason for this is the lack of sophisticated and functional haptic displays and the underdevelopment of haptic design practices and science needed to successfully implement and proliferate them. So basically, there are two major gaps I can see that you're mentioning here is the lack of sophisticated displays. And the second one is the design methods, right? Implementing, as I understand, these interactions and the technology itself. So
Yeah.
based on that, maybe you could elaborate on this a bit more in a sense, what kind of displays are we still missing? Where should we move? In which direction? And what kind of design methods do you think we need to look at? Or maybe any of these design methods that you implement yourself and you see there is a success in that? Because I'm also like a lot working with design methods for designing haptic content. And I'm very curious how you feel. What are the methods that
Yeah.
helping designers to create something meaningful?
Yeah, no, that's a really good question. So, like haptics, as you're probably aware right now, like the field is very multidisciplinary, and there's a lot of people, a lot of different disciplines coming to bring their point of view on these problems. I do mention though, kind of like this idea that we still have a haptic display problem, and I really do kind of believe that. We have really great vibrotactile displays. We have these kind of kinesthetic robots that you can grab and pull onto. But I think we've still not managed to really unlock power of a lot of haptics of our sense of touch. Specifically in my lab, we focus on a much more spatial aspect to displays than kind of prior work. So I've been really inspired by really good spatial displays of the past. There's a display called the Opticon that you might be familiar with. It had 144 tactors on a single fingertip. And it was this great thing that people could take, and it was, well built, and you could control it fairly well. And then all these people kind of bought them and started doing really interesting things with them. And designers, I'm sure, bought them at the time, and people with vision impairments. And the availability of that hardware allowed people to kind of play around and develop different applications and study how to interact with that display. And I think it's only because it was so, maybe overly complex and it could do so many different things with 144 actuators that it really gave people a wide open area to play with. And I think that is when you talk about sophisticated and kind of functional displays, like they need to bring a very wide design space to bear on the subject.
But are these people that you're talking about who got this device, Opticon, probably they are mostly researchers, right? In the lab,
Yeah,
not like someone outside of the field.
it is. Yeah. So there's sort of like the core devices need to just get better. But other parts of my work, I've seen a lot of designers and people trying to get into the field and they're grabbing things off the shelf. They might grab an LRA or an ERM or something and they're fascinated by controlling it. But then they very quickly realize like the range of things you can do with that is not very big. So they're like they're grasping for more and they're really exploring these things, but they end up usually with the same type of use cases kind of over and over again. So you do get into this like cycle of like we don't have the displays, so the designers can't play with them, and the designers can only have what's there, and how do you inform what displays to make. I'm actually really inspired by some of the early work by Camille Mosset. He did his PhD in UMIA. And if you look up his PhD thesis, he's at Apple now. He's been at Apple for a while. If you look up his thesis, though, he talks about simple haptics and like putting these mechanisms into the hands of artists and designers. And he talks about how that's really empowering because haptics itself, the material of haptics is like these devices, like is this physical thing that you have to build and construct. And I think for him, kind of going through that learning process was critical from a design perspective to really understand. And we just don't have those artifacts necessarily right now.
So it's about accessible tools, right? That not necessarily just a mechanical, electrical engineer can use, but a designer, right, with a design mindset can have and play with, right?
That's right.
Yeah, and that I think your point there, Craig, is that it's hard to get to that point if you don't have the hardware, right?
Yeah.
If you don't have the medium that can even express these, more complex touch sensations, there's always going to be a limit to how creative you can be with it, right? Like Camille's done really interesting things at Apple, but always constrained within this like vibrotactile world, right?
Yeah, I know in my own practice. So I had to design our own kind of system that, would allow us to basically prototype different sensations before we actually build the hardware, right? There is a good work also by Oliver Schneider and Professor McLean from British Columbia, right? So they talk a lot about this type of accessible devices that you can just play with content and create stuff. I'm curious about your also opinion about involving users, the end users, let's say, in the design process, like involving participatory design methods. Have you tried using those in your practice, or it was not necessary? Because it's not always needed, not for it.
Yeah, it's incredibly valuable. And, you mentioned Oliver. Oliver does a great job of doing this and kind of interviewing both experts and novices. And we've used his haptic experience model actually a lot to kind of frame how to capture the experiences that we create. I don't use a lot of participatory design every day. We tend to, since we're so close to the device, we tend to focus more on kind of psychophysical methods and kind of really capture, how functional a device is, what's the range of sensations you can get through it. We talk a lot about having a very expressive interface and high expressivity. And that is one of the core things that led us to say, like, there's more expressivity maybe in like these large numbers of actuators and kind of distributed actuation on the skin, and not just focusing on one or two vibrotactile things, but like what if we had 50 actuators on the hand or 100 actuators on the hand? Like that starts to open up a much more expressive type of experience.
Because I like also to go back to the definitions. When we talk about expressivity, what does
Yeah.
it mean in the haptic world?
Good question.
Is it about bandwidth of communication? Is it about
Yeah,
type
it's
of information we can convey? What is expressivity?
I think people are still looking for different definitions. Oliver Schneider's HX model, I think, is great to kind of capture things. I've also been recently inspired by a paper by Hong Tan and Segmun Choi, where they look at what's called information transfer between a person and a device. And that just tries to capture like raw bandwidth, like how many different stimuli per second can you understand? And it's, from experiential standpoint, it's kind of crude, but it does give you a really nice number that says like, okay, if a device is very expressive, you should be able to easily understand lots of different stimuli that you're trying to kind of understand or trying to communicate. And you should be able to do that in a way that's very easy. And I don't have to learn all these things, right? I don't want to have to learn some new haptic language necessarily. I want to feel, oh, that felt like left, that felt like right, that felt like up, that felt like spiral, that felt like explosion, that felt like raindrops, that felt like all these things that maybe just have kind of intrinsic properties to them that I can recognize. And then that starts to build out like a more, what I would call expressive interface.
Yeah, it's always like a compromise between the bandwidth, right, like the psychophysics, and then the amount of information we can actually.
Yeah.
Well, let's then maybe talk more about the displays, right? Specifically the one that you both work on, as I understand it, the same technology that you use, right? In your startup, Joe, right? Fluid Reality, and also in your research, Craig, right? So I've never worked myself with technology, but as I understand it involves this electro-osmotic pump arrays, right? It's kind of like this type of, I know pin array displays, but this is something new for me, for instance. Maybe you could talk a bit with technology, right? What it does, how it works, first of all, right? And
Right.
then advantages, disadvantages, pros and cons in comparison to pin arrays or any other actuation techniques, like vibrotactile, for instance, which is the most common one.
Yeah, I'll definitely let Craig talk about the technology, but first, I think it's important we talk for a second about why it's important. We've talked about expressivity and haptics and why people want to use it and stuff like that. What I think the real important insight and what Craig and I kind of are eternally seeking is to make haptics really useful for people. So our experience at Tanvas kind of left us with deep understanding of what people were trying to do commercially with haptics, also a deep understanding of what kind of the limitations of current technologies are. And there was basically this huge gap that Craig was talking about in the spatial landscape. The sense of touch is much more than vibration. It's much more than just force feedback. So I think the kind of the founding idea and the goal behind fluid reality is to really open up that space, right? How can we get closer to this type of universal display that really is an interface between the digital world and the human sense of touch. Okay? So I think that's where kind of the problem statement comes from, is expanding this world of actuation, because once you do, you can expand all these other things, right? You can start to use it as a display. You can start to do design and communication. You can start to do teleoperation. You can start to interact with virtual worlds and VR and stuff like that. So I'll tee that up to you, Craig.
Sure. Yeah, I think that's a fantastic point. Like, and I just want to reemphasize that this technology that we work on now, yeah, it was not like an existing thing. We really started with like, what would a technology look like that did these things that we wanted it to do, which was have really small kind of pixels and kind of create direct pressure under the finger. And then I basically hunted down through the literature. Okay, we want to create pressure with a fluid. What's the best way to do that? And it turns out that there's this effect, electrohydraulic effect called electroosmosis, that's been used before. And then we really built up the technology around that. So I won't go too technical into electroosmosis, but essentially, you have two electrodes and there's a membrane, a porous membrane in between. The electrodes are kind of porous as well. You apply an electric field and there's kind of configurations of charged ions in the fluid. That field pulls on those ions and kind of creates a rectified flow in one direction, and that creates a pressure as well that kind of inflates a top membrane that's coupled to your skin. That's the core of how
Very fluid, right inside, or it's air,
it's
essentially.
fluid. It's an actual hydraulic,
Mhm.
kind of
Mhm.
electrohydraulic effect. Yep. And then really that was the core effect, getting that to work, and then figuring out kind of the integration of how do we integrate this maybe with, lots of these. So how can we integrate routing from printed circuit boards and flexible printed circuit boards? How do we seal things? How do we do all these other things that kind of need to be done to create lots of these in a very small area?
Mhm, mhm.
Yeah.
But how is it, let's say, better than other actuation techniques? Like, how did you get to this idea that this will be actually better than, let's say,
Yeah.
in arrays, or we can also have, maybe it's a size, I don't know, what matters, but what is that advantage?
I think, just technically speaking, it's a size advantage. So
Mhm.
what we were trying to optimize was how much displacement can you get out of an actuator for the actuator's given size.
Mhm.
And that's kind of what it comes down to. So there's a lot of interesting materials out there, dielectric elastomers, piezos, I don't know, I could go on and on. But they're all like pretty limited in how far they can move. And we decided that you need to be able to move probably a good fraction of a millimeter, and we want the device to be maybe less than a millimeter thick. And so that's a pretty hard design constraint on what you need to create. And we are able to do that with electroosmosis.
Craig developed this core technology at Carnegie Mellon as a postdoc. We were working apart from each other for the first time in 6 or 8 years or something like that. And I got to watch this on the sideline, and Craig's posting new videos about this electroosmosis thing that he's experimenting with. And the whole time I'm just like, if you can get this to work, like this is amazing, because this solves problems in haptics that have existed like the entire history of haptics, right? Like you mentioned pin arrays, Yulia, and you know every attempt to create a pin array in the past has kind of come down to this limitation where the actuators are too big to get to the resolution that you want the pins to be, right? So you end up with this really annoying problem in that you have to kind of come up with these weird transmissions to, fit all the actuators somewhere else, and then find a way to, get that motion down to a small point, or small points that you want on the fingertip. So there's like all kinds of examples in literature where people are building room-sized devices, or they're doing these complex pneumatic things where you have like a pile of compressors and valves and like hundreds of tubes and stuff like that, and you're all trying to get down to this small point. So what this technology does, and why it's so exciting, and why I immediately jumped on top of it, is that it gets rid of all that, right? Like you can do extremely high resolution haptic actuation in an extremely compact package. So that is the real key from my perspective.
Now it makes sense for me, everything actually. The name of the company, Fluid Reality. Basically, the main difference is this fluidity, right? It's kind of like a borderless, right? No borders display, right? Because this, how would you call this pumps, right? This kind of how indentations that happen in the display, they can happen anywhere, right? So they're not constrained by specific location, right? They can move across the display in any way,
Yeah,
or
that's
because
right. You can really
basically you
Yes.
have
think
to
of it
find locations.
yeah, you can think of it like, you have 100 pumps underneath your finger,
Mhm, mhm.
and they're all completely independent from one another. So
Right.
imagine, each
Right.
one's a little pixel, and they're like making a line, or they're making a circle,
Mhm.
or they're making
They're
animation.
not predefined, the locations, right? It's not like
They are predefined, but they're just so small and there's so many of them
okay.
that's like it's like your computer screen, right? Like you can make a
Mhm,
picture out of a bunch of pixels.
mhm,
It's
mhm,
that
Right.
same.
Exactly. And on the point of, the name of the company making sense, Fluid Reality is actually, kind of a double entendre, or maybe triple entendre, in that yes, we're, working with fluids, first of all. That's,
mhm,
clear point. Then the haptics is fluid, as you're saying, right? Like things are fluidly moving around your fingertip, like in a cohesive way, like they are with the display. And then there's the reality piece of it. So we're trying to make, this transition between the physical world and the digital world, and actually back to the physical world again, as fluid as possible, right? So it's a fluid transition. It's natural. You're doing things in the digital reality as naturally as you would in physical reality. So there's a lot of fluidity going on.
mhm, mhm, mhm. Yeah, I see that. Well, very interesting. And one more technical question. I'm curious myself. So, in terms of parameters, it's modulation, you can do the same parameter modulation, like, I don't know, amplitude, frequency, all that same stuff as usual.
Yeah, it's a sort of a analog type effect. So the more voltage you feed to it, the larger the pressure. It's pretty fast, so you can switch it back and forth. We found the most compelling effects, or kind of the thing that it can do differently, is typically this kind of static indentation pressure, where you just turn this thing on and it kind of pushes up into the finger. But also kind of creating these dynamic patterns is really, really unique to this technology, to kind of create
Mhm.
the effects. It's hard to describe effects, but the effects feel much more real, and kind of like an indentation pressing onto your skin and traveling around your skin. So it's,
Mhm, mhm,
but
mhm.
we have been able to do other things as well.
Yeah, I'm already like having lots of ideas how this could be applied. And that's probably a good transition also for us to talk about the future of haptics, in a sense of compelling use cases, right? You can talk about also where fluid reality kind of heading, right, in terms of being useful to the society, right, or community. What are the compelling use cases? That then, in general, maybe you can share your view where the haptics industry is moving. Where is the future, right? Let's say if you have someone starting a career in haptics, let's put it way, where should they look at? Something in those
Mhm.
lines.
Sure. I'll take a crack at that. To me, haptics as a field has sometimes struggled with, this exact question, like what is it most useful for, right? Like I think the average person on the street can think about the sense of touch for just a second and realize, this is extremely useful, right? Not only is it useful, it's, I couldn't live without it, right? I couldn't unlock a door. I couldn't eat a sandwich. I couldn't, take a drink of water without, the sense of touch in my fingertips. That has never really translated very well into digital interfaces, right? So certainly in knobs and buttons, certainly, in clicks and stuff like that. But the digital world and the digital interface that most of us are interacting with every day doesn't really have this physics element to it, right? And the sense of touch is all about physical interaction. There's some, kind of pseudo physics going on in momentum scrolling and, phone icon layouts and stuff like that. But it's really, just that kind of a surface level. The really exciting thing to me is the new future in robotics, right? So whereas haptics is, the connecting the physical and digital world, robotics is connecting the digital to the physical world, right? So we are at Fluid Reality most excited about applying haptic technologies to control robotic hands and grippers and fingers. So what this allows you to do is to feel what the robot is feeling, right? So you are now, able to kind of reach across the internet, right? Reach through this digital divide and start to do real useful tasks. And by doing that, by having this digital intermediation, you get all kinds of advantages of the digital world that you just can't take advantage of if you're just in the physical world. You can remove the constraints of distance, for example, right? I can do this across the world. I don't have to travel there. I can remove other physical constraints. So I can all of a sudden be much more powerful or strong, or I can be much smaller even if I'm manipulating things at a smaller level. So you get away from those physical constraints as well. And then there's time, right? We can now get away from the constraints of time as well. Once you've the first level of teleoperation is kind of one-to-one. The robot is only moving because I'm telling it to move. But then the second level is, okay, now I've shown you, robot, how to do this one time or 100 times or something. Now continue doing it, right? I'm gonna go off and do something else, but I'm gonna leave you here to kind of multiply my time, to multiply my productivity and augment my work. So my message, and Craig, I'll give you the chance here too, since you're the professor now. But my message to people going into haptics is really pay attention to robotics, because I think this is where the real work is going to be done.
Mm-hmm. I would like to have a bit more examples even. That would be great, especially with time, right? So, and what kind of more tasks that we can also do. I mean, maybe Craig can also talk about that. Really, really fascinating.
Yeah. I mean, so Joe pointed out that, telemanipulation and kind of telerobotics is really taking off right now. And I think it's a really interesting area for haptics. Haptics is useful in a lot of ways. I do tend to agree that haptics is really good for control and really good for manipulation. So anywhere that you're controlling and kind of manipulating things with your hands, that's where haptics is kind of best served. There are other people doing really great work in entertainment and kind of like aesthetics and things like that. Not to kind of say that's not important, but really when it comes down to it, control and manipulation. And that's kind of why I got interested in haptics in the first place. It was, like I said, I was at this telerobotics company and I was like, how are they doing all these crazy things with their hands? So I think like those trends are going to continue. Like our hands are a tool. They're just a tool that we know how to use better than most tools. And they can couple to other tools and we start to learn how to use those. So using that as like interacting with the computer, I think a lot of people are interested in that for, just pure virtual reality, interacting purely with a computer. I'm also more interested in it for augmented reality, like how do we create like maybe little lightweight interfaces to help us use our hands in both the real world and the virtual world. And then you have kind of the most maybe compelling or interesting case, which is where I talk to a computer with my hands and then that computer talks to a robot in the real world. And now you're really affecting things back in the real world. And you get all these crazy, superpowers, I think, as Joe put it, where we're used to creating and interacting with machines like a giant backhoe or, all the tools on a construction site that let us do these crazy things. But now we're going to be able to infuse that with this kind of digital control and digital communications where we're controlling robots around the world, or we're controlling this giant construction robot, or an exoskeleton like that. Those futures are actually coming to fruition now and will be powered by how we control these things.
So if we talk about that, it's more about kind of industry level, very specialized in a way haptics, right? Like teleoperations for specific tasks, like industry.
Traditionally, that's been the case. Yeah, but this huge influx in robotics and interest in humanoids is pushing us to think more generally and pushing us to think more about how do you create one robot that kind of looks like a human because the world is designed for humans, and then that robot can kind of go off and do things. But of course, there's always going to be kind of specific use cases for the technology.
Yeah.
Joe
Yeah,
Biden.
to add on to that a little bit, my vision of the future and what I think is already happening is that there are going to be thousands and then millions of breeds of robots out in the world, and those are going to be specialized, at some level. Even when we're talking about a general purpose thing like a humanoid, some humanoids are going to be tall and thin and can change the light bulb on the ceiling, and other ones are going to be short and squat, and they're going to be able to lift 250 pounds with their hands. So there's going to be a lot of different general purpose robots out there, but what isn't changing is the human being. People are going to be the same range of sizes and shapes. They're going to have the same range of touch sensitivity and dexterity in their hands and stuff like that, pretty much as far forward as we can think about. So what's really important about that is that you can build the human interface in a way that will sustain, and then connect that to all of these thousands and then millions of robots that are out there. So it's a really exciting world where you can think about kind of augmenting people, giving them control of robotics, giving them this ability to basically multiply themselves into the future.
Interesting, very interesting angle, because usually we talked about with other speakers also about, like daily use of haptics, I don't know, remote relationship and things like that, or well-being, emotional regulations. And your angle is quite different. So it's very useful to think about that direction actually in robotics and teleoperations. Thank you for sharing.
We try to think differently.
Well, I have this last question is more about kind of a social question, because I see that you've been cooperating for quite a long time, and you, Craig, is an academia, right? Journal is an industry, and you collaborate. So there's always, I mean, maybe the US is a bit different, but in Europe is always kind of not easy to find fruitful collaborations between academia and industry, right? So academia is usually like sitting in its own silo, doing something theoretical, and industry is like practical, and like it's not easy to collaborate. How did you make a successful collaboration? What kind of advice could you give?
So I spent pretty much my entire adult life kind of going back and forth between startups and academic research, thinking about making those transitions and how to make them kind of work well together. I think no one is really doing it that well today, and there's a huge opportunity to do it better. At the 10,000-foot view, both academic research and startups and in industry at large have kind of the same goal. It's like we have all this work that we need to do to keep 8 billion people alive. How can we create new technologies to do that better? And academia has its own like set of reward functions, and it's kind of a very specific game, that is a system that is set up with rewards and feedback that produces a certain thing. Startups are also a different type of game, right? There's only certain things that are commercially feasible, only certain things that are fundable, through the handful of funding mechanisms that exist. So kind of there are two different systems, and neither one of them is really optimized to do the thing that we want, which is apply technology to make people's lives better scale. So how do you do that well? I personally was very impressed with the way that Carnegie Mellon University does it. They have kind of a historical outlook, from the founding of the company, that they're there not just to understand the world, but to bring things out into the world. So that kind of permeates through their culture. They've done a lot of very practical things, right? Which is to support inventors and researchers with their new technologies to make that transition as easy as possible, everywhere from funding mechanisms to connections to mentors and education and accelerators and funding mechanisms and stuff like that. Having seen multiple universities do that, I think that, kind of everyone has something to learn from Carnegie Mellon. But then again, it's certainly not perfect. They're living within, the government funding mechanisms. They're living within the venture investing ecosystem and stuff like that. So I think as we look forward, I think reimagining how this is done, I think is a really, really big opportunity across the world.
I agree. I totally agree with you. It's a lot of, there is a lot of potential actually for that. How about you, Craig? What do you think about this?
Yeah, maybe the question is like, why is there more of this activity? Or at least to me, it seems like there's more of this activity going on in haptics than other areas. And I think it comes back to the question of kind of how developed are these core technologies. In haptics, we're kind of learning the technology and building it and studying perception kind of all at the same time. And there is no like general haptic display kind of out there. So that allows these, startups from academia that have these new ideas to really come in and disrupt the industry and disrupt what people are doing in the commercial space, just because nobody's really thought of it before. So I tell my students that, haptics is both an art and science right now. And it turns out that the people doing it the longest are the academics. They've been doing it for 30, 40 years, right? So they have these kind of really deep insights that a lot of people in the commercial space might not have, just because they've been studying it for so long. And they can kind of come up with these new ideas that might have commercial value, might not. And you see a lot of different professors that might have a startup to kind of facilitate looking into commercialization. And then if you all the stars align kind of perfectly, then that kind of goes off and takes a good journey. But I think it really does come back to, we don't have these really practical high expressivity displays that are out in the world. So if haptics researchers want to study them, they have to create them first.
Right.
And that's sort of like, you have to create it, and then that leads to kind of more impact of your work, and your work can kind of build on itself and build out to other people. So
yeah, it's like you have to show the value first, right?
yeah,
So that
you have to show the value.
I did.
Exactly. Yeah.
Same. Well, thank you so much. I really, really appreciate your time and sharing your experience and outlook towards haptics world. So thank you. I think it will be very useful for others to watch this discussion. Thank you, guys.
Fantastic. Thank you for having us on.
Yeah, thank you.